Hi, this is Yosef Bharti, and we are here at Open Source Summit in Denver, Colorado. And today we have with us once again is Steve Watt, Office of the CTO at Red Hat. Steve, it's great to back you on the show. Last time we talked virtually, this is in person. It's good to see you in person.
Yeah, likewise.
Let's start with, of course, the focus is more on AI because AI is the hottest topic, especially when it comes to organizations, how they are leveraging it. I mean, everybody is using AI, but what about open source AI? So before we talk about how folks are using it, let's talk about how would you define open source and AI, because they are not as simpler as Red Hat's LAMP stack.
Yes, absolutely. So we define open source AI as sort of a minimum definition is open source model weights surrounded by open source software components, or the ecosystem and the runtimes that serve those models. It's certainly an interesting space. I think, as you alluded to, there's a lot of varying definitions of that, but that's minimally how we define it. And of course, we'd like to see that eventually expand into perhaps the pipeline itself and the training data eventually as well.
When organizations look at, of course, using proprietary AI is very easy, but when it comes to open source, using open source tools, that's why we talk to Red Hat, right?
Yes.
What are the challenges they face? And now we are not talking just about big data centers, we are talking about all the way to the edge as well.
Yeah.
So talk about what are the challenges they face, and what kind of open source tools are available at their disposal to do it without compromising with their open source ideology.
Yeah, well, I would just start with, where a lot of users are at. Let's start with inferencing, right? Which is using the models or sending them requests, getting responses. And so VLLM is an open source project that Red Hat's I would say the largest commercial contributor to, but it's one of the most popular inference servers for large language models. And so that's a place they can start for serving their models. Then there's a variety of open source models. IBM has Granite, which is a perfectly fine large language model for a variety of different use cases. There's obviously others like Llama, DeepSeek. So you're able to actually get the models themselves. And then at that point, it's sort of what you do next with it. So if you want to fine tune the model, we have the InstructLab project, which allows you to basically take the model and adjust it to improve its response performance as far as like the content coming back. And then the training the model, also we have a full suite of products inside Red Hat OpenShift AI, which allows you to basically train the models, fine tune them, serve them. You mentioned on the edge, right? So edge is kind of an interesting thing where large language models don't always fit the resource budgets of edge devices. And so there's other inference server options, or for maybe predictive models that you can get with OpenShift AI or Red Hat Device Edge to be able to serve models out on the far edge.
This is because Red Hat, IBM,
Yes.
Of course, IBM acquired Red Hat, but you folks still treat each other as, separate kind of entity in your main, that IBM is your client and Red Hat is their client. IBM has done a lot of work in this space as well.
Yeah.
How much leverage that brings to Red Hat in terms of enabling organization to scale, their AI deployment?
Yeah, we work a lot with IBM Research. So obviously, on the product side, we're able to benefit from a lot of the giant IBM channel and the requirements and customer feedback around market trends that we get from that. But on the technology side, we have a fantastic relationship with IBM Research. So for example, to actually build their Granite large language model, they needed to build out a really large infrastructure of primarily NVIDIA and AMD GPUs, and being able to sort of learn from that infrastructure, bring those insights into our products, changes inside Kubernetes, changes inside VLLM, changes inside InstructLab. We're able to use InstructLab. In fact, it actually flowed originally out of that infrastructure from one of their researchers' white papers. And so I would say that's probably the main place. We are deeply connected from the research pipeline. And it's sort of, I run my own research and emerging technologies team inside Red Hat. And so my research team works with their research team. We use a sort of a divide and conquer philosophy, but access to their large scale blowout infrastructure is table stakes for doing it. You got to have the equipment, the GPUs to be able to do anything meaningful with AI. And they really help us out a lot on that.
Since I'm talking about IBM, and this might not directly relate to that mainframe,
Yeah.
Also IBM did a lot of work with the open source, there's a whole open source project, an open mainframe project.
Yes.
What is the scope of AI there? Because also IBM announced Linux 1 ages ago to enable, those workloads. Or you're like, well, this is too early, because if you look at mainframes, they are like older than me. And when we look at AI, it's not even a toddler.
Yes. Yeah, mainframes are kind of an interesting thing because I think it's all too easy for us to think, oh, those are an artifact of the past. It's actually still an incredibly profitable business for IBM. And there are lots of people still using mainframes. So like you mentioned, the Linux 1, there was a journey from mainframe to basically how it can run containers and Kubernetes and OpenShift on those. And just likewise, the same thing with large language models, inference servers. The mainframes can do all of that and benefit from terabytes of memory storage, memory availability to the applications that are running on it. So absolutely a place that we're looking to invest in. Specific use cases where mainframes and AI are becoming working together well, like code assistant, code completion, being able to sort of power the services that provide that. Very popular, successful use case on the mainframes.
While we are talking about hardware, I also want to talk about Red Hat's commitment, contribution to projects like PyTorch, Triton for hardware accelerator inferencing.
Yeah, this is, one of the things that I think makes Red Hat special is we're all about optionality. So what we're trying to do with our hybrid cloud message, which we've had for a decade now, is, look, we want to give you one experience to develop your software and one experience to manage and operate your software that works the same regardless of whether you're running on Amazon or Google or Azure. It's just one thing to sort of train your IT staff and your developers on, and you can configure it for anything. So how do we take that to this new ecosystem of AI, right? And you had the Linux kernel ecosystem, right? Then you had the cloud native ecosystem. They're different worlds. They work on top of each other, right? Cloud native works on top of the Linux ecosystem, but it's a different ecosystem. And the AI ecosystem around PyTorch is even different, right? Like it's a separate conference. It's not Cloud Native Con. It's PyTorch, right? So what we're trying to build those same values inside PyTorch ecosystem, and we're very involved in the Triton project, where essentially Triton is a DSL which allows you to basically write GPU agnostic kernels. So you can basically write the kernels to enable whatever frontier model is being released in VLLM. And once those kernels are written, it'll work on NVIDIA or AMD. So whatever GPU infrastructure you have or you've already bought, right? It'll ensure that those models will be able to work across that. And so it's sort of like a software portability story there. And so we've been quite involved in the Triton project, and it's a core dependency of the PyTorch project itself.
And for those who may not know, can you also tell them that what role is VLLMs playing in high performance AI?
One thing I think is quite interesting is AMD just had their, I think, Advancing AI conference in the Bay Area last week or the week before, and they were sharing performance numbers over there. And it was interesting how people were characterizing what performance looks like, right? And so what they were doing is they were using, DeepSeek and Llama as two specific models running a variety of like ML Bench or ML Perf tests against those on their hardware versus other hardware on that. And so VLLM is specifically, it's an inference engine specifically designed to do high performance token throughput, right, for your models. And like you might think on this, like I think with a human's patience for getting a request and response, it's like 50 milliseconds, right? You type in the Google search, you hit enter, Like if it takes more than 50 milliseconds, you start to get annoyed. There is that aspect of inferencing too, but where it becomes so important is agentic, right? And so when it's agent to agent that are all hitting these different models, or machine to machine, inference performance becomes really important. And another dimension that's so interesting with agentic is if you look at the demand that it puts on the model itself, right? Where today it's humans using chatbots, submitting requests to models, getting responses back. That would probably scale to like the amount of humans on Earth and a certain amount per day. But like agents will take that several orders of magnitude higher. So it's how do you increase the demand but then still maintain the same throughput and performance efficiency. And that's basically why we created LLMD, which was to basically under duress, which we anticipate with the rise of the agentic ecosystem, how can we scale what's essentially like a single server architecture to a distributed system, just in the same way we went from scale up to scale out with cloud native. In the same aspect, we're doing that with inferencing. How can we distribute the components of the system across the cluster? And so as you ramp up the load, you're still maintaining the same performance and not delaying time to first token.
Excellent. Once again, thank you so much. I mean, agentic AI has become, everything becomes hot topic, right? In the especially AI field. And organizations, sometimes they do want to jump quickly and start, and sometimes they are still, peddling the water, trying to figure out. Also, a lot of industries are highly regulated industries. There are a lot of apprehensions about it. I remember discussions like 2 years ago when it comes to the discussions were different. They were like, but now when we look at it, the adoption, where are organizations when it comes to agentic AI? Also, yesterday's announcement, A2A. So let's talk about what kind of evolution you're seeing in the agentic AI space and how prepared organizations are to adopt it while they're already thinking of adopting Gen AI.
Yes.
So it should be like a step. Let's start here and then move to, or you're like, no, this is.
I think it's a great question. I don't think it's that different to past software shifts we've seen in the past, right? It's still humans have to learn technology. Humans learn at a particular rate, and they have to go through that same learning curve. However, the experience is like, where am I going to run what model am I going to inference against, build my agents against? Where's that going to live? So once you've figured that out, that's the same as deployment stuff we've been dealing with the last decade. Once you've figured that out, then it's how do I become productive building applications on that? And so, as you mentioned, there's different frameworks. We've been very involved with Meta partnering on Llama Stack and have added a lot of capabilities to Llama Stack, specifically enabling like retrieval augmentation with fine tuning, incorporation of specific vector databases inside the Llama Stack ecosystem, and enablement of model context protocol, which is another agentic framework that we've been strategically investing in partnership with Anthropic. And but you're right. Once they get going, people will start with their first agent and then it's human to agent, or it's agent to agent is the next evolution as they become more evolved. But as you go to that, okay, I'm going to take you back. Okay. So do you remember when web services was first created? And you had the simple object access protocol, SOAP, then you had enterprise service buses and all the different standards and security that came through all of that. It seems like it's kind of flowing along a similar dimension where, great, you can create the discrete services, the agents, but then you have to orchestrate them and get them working together, the actual pipeline of all of this. And that's where we are as an industry. That has security implications around how do you pass identity through? How long does permissions last? What kind of permissions? How are the permissions different from you as the person that's telling the agent to do something versus the agent? Are permissions time bound? So identity, authorization, all of these things are now getting built into these agentic frameworks. And so I think as the applications right now are functional and there's a lot you can do with them. We've still got to bring in the non-functional aspects of any software ecosystem into the agentic architectures, and that's where we're focused today.
And since we talked about the A2A protocol yesterday, and since you mentioned the whole web, will there be like one protocol? I mean, I also understand,
One way to rule them all?
Yeah.
I don't know. It's hard to tell. It feels a bit like when serverless first came out. There were a lot of different serverless frameworks, and it took a while to identify which one will become the most popular, right? There's obviously Lambda, which was a service, but as far as like open frameworks that allowed you to run across a variety of different infrastructures, eventually Knative rose and became like the dominant thing. I feel like we're in a space where that's emerging. Red Hat is unusually good at, I think that one of the main benefits we provide to our customers is navigating these new projects and these new technology trends and trying to identify where the community is going and where the place to invest is in that. And then basically back in those projects so that the customers have something that they can build and rely on. We're still in this space with MCP. It's very early on Agentic. I think there could be lots of other projects that still come out. So we will do what we always do, which is navigate, track, follow, and then identify which one will become the winner.
No, it's a great answer, and it's a complicated space as well. I think I have most of what I was looking for. One more thing, of course, there is Llama, and a lot of stacks are emerging. Once again, we don't want one stack to win, but
it's a very open source statement.
But they should be able to. It should not become a fragmented space. It should not become their own containerized kind of, because it should be like email.
Yeah.
That
open standard.
Yes, open standard. So what kind of discussions are going on, or you're like, it's too early, the market is still evolving, but sometimes when the market evolves and becomes too big, like I cannot send a message. I mean, of course, Facebook Meta owns Thread and Instagram, everything else, but I cannot send a message from Thread to, you understand what I'm trying to say?
Yeah.
So how do you see this space, and what you're like, this will be the ideal situation?
I see the problem, and the way I kind of reason about this is what feels unprecedented right now is the amount of creative destruction that's happening in artificial intelligence right now, which is a simpler way of saying that is one project gets created, the industry rallies around that. 3 months later, another project gets created, the industry shifts their attention to that thing, and that last thing is not the thing anybody's using anymore. That's got all kinds of implications around our open source model and world. Think about if the time to commercialize a new technology, open source technology, shrinks to a certain point of time, like the ability to create companies that provide stable, supported distributions of open source projects, it becomes very hard to create successful companies in that environment. And so that is something everybody's navigating. And so then the question is, well, if that's the case, what is stable? It looks like PyTorch is stable, right? So to me, like, what's the anchor and the nucleus of this ecosystem? PyTorch is, and then around that, what is the stack that's coming around PyTorch as you move up? VLLM, from an inference server standpoint, seems to have enough inertia and critical mass around this. Both of these are projects with healthy enough governance models where it's open and doesn't give me cause for concern that the projects will get hijacked or they have problematic governance models. And beyond that, those are the two sort of key technologies. There's, in training and fine-tuning, there's other projects as well, but I would say those are the two anchors that I think the industry needs to sort of rally around right now.
If I ask you a very simple question without any drama, what is going to be the Linux of It's a very simple question.
It's actually a
More complicated question than you realize, but it's a great question. Like, the reason I like this is like, if you look at technology, at least the way I reason about it in my brain is there's been three key shifts. So there used to be scale up, right? Like the LAMP stack you were talking about. And that, with that, Linux operating system was sort of the surface area upon which you build your applications, okay? And then containers and cloud orchestration came along, and the world shifted to distributed systems. And Kubernetes sort of arose as like the nucleus core ecosystem project for that. And the stack or the platform went up stack, and the surface area in which you build your applications ran on Kubernetes, right? And so you had just a different class of applications. The Linux applications still exist, those still exist, but Kubernetes ran on Linux, and Linux solved a whole bunch of different problems. So I wouldn't say like Kubernetes replaced Linux, because I know. Because Kubernetes benefited from all the hardware enablement that Linux did for x86. AI is different, and right now we don't have that hardware abstraction. So the problem needs to be solved, like recreating Linux or that abstraction in AI has a couple of different vectors you have to tackle. One is hardware. How do we create a consistent abstraction across the things that models run on, right? So there's GPUs, there's TPUs, and there's this wild west of accelerators, right? Grok, Cerebrus are a couple of really interesting ones. Some of them are inference focused, some of them aren't. So we've got to be able to enable those in a consistent abstraction in the same way that Linux did to the thing. Okay, so that we're still working on from an industry standpoint. And Triton's very interesting. It's a step forward there, but Triton is just the answer for GPUs. It's not necessarily the answer for TPUs or NPUs or accelerators. Then if you go higher up the stack, VLLM is that next class of applications where if you look at the surface area upon which you build your applications, it's using the OpenAI protocol, the interface. And that class of applications I would categorize as the agentic space. And so I think VLLM is doing a really good job of creating that new surface area for AI, for model inferencing. PyTorch is at the lower down for fine-tuning and pre-training. But it's a sort of like a hard question to answer. There's a lot of things that still have to converge.
I sometimes wonder that we should just start saying that Linux is the gold standard when it comes to can you do what Linux has able to, as you give a great example of, how Linux solve all the problems. If not, then no, you still have, a long way to go. I think we have hit on all the major points that I wanted to talk to you about. Yeah. Is there anything else, or you think that we hit on all the major points?
I think Linux benefited from the fact that there was just x86, for the mass enterprise market. And then later ARM came along and it was able to sort of extend to ARM. And now it's sort of extending to RISC-V beyond x86. I think that being able to do that across GPUs, TPUs, NPUs, accelerators is sort of like the next grand challenge in that space.
I agree with you. Only when somebody asked Neil deGrasse Tyson, who would you consider, the smartest, whether it was Einstein or Newton, he says Newton, because Newton did not have any shoulders to stand on.
Yes.
By the time Einstein came, there was a whole. Yes. So when Linus created Linux in his, basement, he did not have any shoulders to. FSF came, and they were building their kernel. But yes, you're right. But at the same time, he did not have the world that we live in today.
Yes. Yeah.
But yeah, it's
very much a Linux world. Yeah, I hope you're not hearing from Red Hat that it's not about Linux.
Exactly, that's what
No, that's not what I'm saying. I'm just saying there's a lot in the AI ecosystem.
I understand the nuances. I just wanted to I just want to say that Linux value, the foundation it has built, it has become a kind of foundational. Everything is built on top of those. This is not a shoulder of a giant. It's a giant itself, So,
absolutely,
it's kind of incredible the journey Linux has. I mean, we have not seen any technology in history that was created from there and where we are now. I mean, whether it's Mars or in the middle of ocean, it's all Linux all the way, and Red Hat is, you folks use SUSE, because the biggest problem with open source is sustainability, survival, and making enterprises comfortable with that. That's what Red Hat did.
Yes.
So it was not free. You don't have to struggle with free as in beer or free as in freedom. It's open source. Go and use it, make money from it. So once again, Steve, thank you so much for sitting on with me,
Always
and a great
pleasure.
discussion as usual. And I look forward to chat with you again. Thank you. Thank you.